Okay, I'm going to do a second video now on factoring trinomials with a lead coefficient that's not 1. I'm going to start with number 5, and I'm going to do a couple other methods with this one, give you some different examples of approaches. You will find that some approaches you prefer and some approaches you don't. I personally prefer factoring it all, factoring the lead and coefficients completely into prime factors because my brain works better seeing all the different combinations of the prime factors. But some people will prefer to do this approach, which is to take the lead coefficient, in this case, which is 6, and multiply it by the end coefficient, and I get 66. Once I've done that, I look for two factors of 66 that add up to my middle term. My brain doesn't immediately see it, but upon some thought, I've got factors of that. I can say, okay, 1 and 66 are factors of that. I'm just going to list the factors first. Oh, it thinks that I am doing something different than I'm doing. So 1 and 66, that doesn't work. So that's 67. That's not 25. Then 2 and 33 doesn't work because that's 35. And 3 and 22, well, that one looks like it will work because that's going to give me 25. Just for thoroughness, I will complete the list. 6 times 11 gets me 66, but 6 plus 11 just gets me, pardon me, gets me 17. So this is the one that I like. Okay, so nope. And these are all sums here, but they are sums of factors. Okay, so I've got nope, nope, and one that is good. So now I need to come up with a way to arrange things so that either my inside or my outside is 6t, and my other one of those two is 11t. So here we go. It's easy to get the outside one to be 6t by making that 1. Okay. I'm sorry. I apologize. I'm not looking for 6. It's easy for me to, I'm going to get a 3 here. Okay, so it's easy for me to get a 3 for one of my products, and then I need a 22 for my other one. So in this case, that means that if I have used my outside product, let me step back. If I make my outside product 3t times 1, which gets me 3t, then I have used 3t of 6t squared. So my first is going to be forced to be 2t on the other one. Okay, now my last needs to be 11. I put a 1 here, so we'll put an 11 here. And we're going to now test to see if we got it right. Okay, so my outside is 3t. My inside is 11 times 2t, or 22t. And yes, I've got 3t plus 22t, and I am good. I've got what I need. I have factored this. I've also confirmed that 3t and 2t multiply to get me 6t squared. And my last term is provided for me by 11 times 1. All right. Now, on this number 6, I'm going to do it similarly, but I'm going to then do it as a factoring by grouping approach. So, on this one, I'm going to take 3 as my lead coefficient and 20 and multiply them to get 60. And now I need two factors of 60 that add up to 17d. Ultimately, they need to add up to negative 17d. So we'll work that out. So what I need is two factors of negative 60 that add up to that. So I'm going to put a negative. I'm just going to leave that alone. We'll come back to that. So 60 could be 1 times 60. But now it's doing that thing again. So 1 plus 60, I'm adding one of the sets of factors, so I get 61. 2 times 30, but that gets me 32, and that's not what I want. 3 times 20, so 3 plus 20 gets me 23. And then 4 times 15 gets me 19. I'm a little closer now. And now 5 times 12. 5 times 12 is 60, and that gets me a 17. And that's what I wanted. And then, but I really want -5 and -12 to get me -17. So, what I'm going to do now is I'm going to take, so, nope, 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 nope for those, but this one is good. Okay, so now I'm going to break up my -17 into into 5 and -5 and -12. So I'm going to have 3d squared minus 5d minus 12d plus 20. Okay, so, and I'm going to show you that it actually doesn't matter if you did it -5d and -12d or -12d and -5d. It'll work either way. So, I'm now going to group this. Okay, so I'm going to put parentheses around this. Plus -12d, because that's a way to keep track of that negative. Okay, and I'm going to see what my greatest common factor is in 3d squared minus 5d. My greatest common factor there is just d. So I factor out a d, and I get 3d minus 5. And over here, I'm going to factor out my greatest common factor. My greatest common factor here is going to be, well, I don't have any d's to factor out, but 12 and 20 share a common factor of 4. So I'm going to factor out a 4. I'm going to make it a -4. If I make it a -4, then I'm left with 3d. So I'm going to start off by making it just a 4. Okay, I'll factor out a 4, and I'm left with -3d plus 5. Now, if you look here, I've got 3d minus 5 and -3d plus 5. I need these to be the same, but it's easy to make this the same if I factor a negative out of both of them, because then I end up with positive 3d and -5. So I have the same factor on both of these, which means to do that, I had to make this -4. Okay, now I look at this and I see both of these have the same factor, 3d minus 5. So I can factor out 3d minus 5, and the other factor is going to be d minus 4. And then I'm going to test it all, see if it works. So 3d times d is 3d squared. -5 times -4 is going to be positive 20, so that's good. Then I look at my outside. 3d times -4 is -12d. -5 times d is going to be -5d. So I've got -12d and -5d, and that adds up to -17d. So I am in good shape. So I'll say 3d minus 5, d minus 4. Now, I promised that I would show you that it did not matter which way I did this. Instead of doing minus 5d minus 12d, I'm going to make it minus 12d minus 5d. That's saying the same thing. It's 3d squared minus, this is negative, minus 17d plus 20. Now I'm going to group that with some parentheses. And to keep track of my negatives, I'm going to make that addition right now. Now I'm going to factor out the greatest common factor of each of these pieces. So 3d squared minus 12d, I can factor a 3d out of that, and I'm left with d minus 4. Oh, look, the d minus 4 that I was after over there. Then, pardon me, I'm going to factor here. I can't get any d's out, but I can get a 5 out. And as you noticed earlier, I'm looking to get a d minus 4. Since that's positive, I'm going to go ahead and factor the minus 5 out, because when I factor negative 5 out, I get positive d there, and negative 5 divided from 20 is negative 4. So now I have the same factor for each of these parts, and I can factor it all out, and I end up with d minus 4, since they both share that factor, and then I can add them together, 3d minus 5. And I test it all out. My lead is 3d times d, so that's 3d squared, so that's good. My first is 3d squared. My last is negative 4 times negative 5. Again, that's still positive 20. My outside is d times negative 5, so negative 5d. My inside is negative 4 times 3d, so that's negative 12d. Negative 5d and negative 12d gets me the negative 17d that I wanted. So this works as well. And this is just commutative property. You can reverse the multiplication. And there you have it. Works either way. All right, I'm going to pause making videos for right now. I'm hoping that these will help you with the rest of them. But I'm going to go ahead and add to the answer key now and post that. Hope this has helped. Thank you.